So now that we've spent a lot of time with Pythagorean theorem, what we start to realize is that there's problems that apply to Pythagorean theorem, or where Pythagorean theorem can apply. And one of those is being word problems. So on word problems, they're going to use terms that refer to the legs of the hypotenuse or the legs or the hypotenuse. So like if you see such words as north or south, a pole, or the height of something, then that's referring to the leg that's going vertically. If you see east, west, shadow, base, or width, then that's referring to the base or the other leg that's going horizontally. And anytime it's referring to the hypotenuse itself, a ladder, a rope that's going from a pole to the ground, diagonal, or the word ramp, then you're referring to the hypotenuse on those. And then we're just going to apply Pythagorean theorem. A squared plus b squared equals c squared. So if we read number 1, it says Jane and Zachary started walking at the same point, but Zachary walks 5 feet north while Jane walks 75 feet east. How far apart are Jane and Zachary when they stop? So if Zachary is walking north 5 feet, so the north side of the right triangle is the up and down, the vertical, so I'm going to put 5 there. Jane walks 75 feet east, so hers is going to be the other leg. They want to know how far apart they'll be if he's walking north and she's walking east. So that distance between them is going to be the hypotenuse, the c. So remember, if we do a squared plus b squared equals c squared, a and b are my legs, so we're going to replace a with 5 squared plus b squared, which is 75 squared, and then c squared. So if we clean this up, I type in 5 squared, that's 25, and then 75 squared is 5,625. So to add those two numbers up, 25 plus 5, 625, remember we add when we're looking for the hypotenuse. So we have 5,650. But my final answer, remember, is to take the square root of that number. So the square root of 5,650 is a decimal. So C equals 75.2 if I round to the tens place. Let's keep going. Number 2, the length of the diagonal of a television is 20 inches and the height of the screen is 12 inches. What is the width? So when we're talking about a television screen, we know that the television itself is not a triangle. It's actually a rectangle. And then when they're referring to the diagonal of a television, that's the distance from corner to corner. So that's 20. And the height of the screen is 12 inches. They want to know what the width will be. So there's the right triangle. So we're missing the leg, or one of the legs. So if we do a squared plus b squared equals c squared, a squared is 12 squared, plus b squared we don't know, equals c squared, which is 20 squared. If I clean that up, I've got 12 squared, which is 144, plus b squared I don't know, and 20 squared is 400. Now, when a leg is missing, we don't add these numbers, we subtract them. So 400 minus 144 is 256. And then my final step is to take the square root of that to actually find how long b is. So b equals 16. The width of the television screen is 16 inches. Carly goes to visit a friend. She travels north for 20 miles, so north is the vertical, and west for 25, so 25 west is the horizontal. Her friend tells her to turn on a diagonal to go back home. How far is the diagonal? So they want to know how far the hypotenuse is. So if these two are my legs, I've got 20 squared plus 25 squared equals c squared. So 20 squared is 400. 25 squared is 625. So 400 plus 625 is 1,025. And so the final answer is to take the square root of that. And so as a decimal, my hypotenuse, if I round to the tens place, is 32.0 miles. Bobby leans a 15-foot ladder against his house. So the ladder in my diagram here is the hypotenuse. So the 15-foot goes there. The base of the ladder is placed 4 feet from the base of the house. So if you see the word base, it's referring to that. So 4 feet. They want to know how far up the ladder reaches the building. So they want to know how high it is. So we have the hypotenuse, we have a leg. So we're missing the other leg. So a squared plus b squared, which is 4 squared, equals 15 squared, because that's the hypotenuse. So we don't know what a squared is, but 4 squared is 16, and 15 squared is 225. Okay, now remember, if a leg is missing, we don't add these two numbers, we subtract them. So 225 minus 16 is 209. Then to get our final answer, we take the square root of that. And so the height of the building, or how high the ladder reaches, is 14.5 if I round to the tens place. Troy is building a rectangular garden. So here's the rectangle. That is 10 by 6 feet. So 10 wide, 6 feet long. What should be the length of the diagonal? So if I want to know how long the diagonal is, and we're talking about a rectangle, then that means the diagonals that goes from corner to corner. So we're looking for the hypotenuse. So if 6 and 10 are the legs, we've got 6 squared plus 10 squared equals c squared. So 6 squared, is 36, and 10 squared is 100. We don't know c, so 36, remember if we're missing the hypotenuse, we add 36 plus 100. So we got 136 equals c squared. And to get my final answer, we take the square root of that number, which will be a decimal. If I round to the tens place, the hypotenuse is 11.7. A foot ramp is used as the loading dock at a facility. If the base of the ramp is placed 8 feet from the base of the dock, so there's the word base, so there's 8, how high is the loading dock? So I forgot to put a number there. I believe it's supposed to be a 12-foot ramp, okay? So if a 12-foot ramp is at the loading dock, so the ramp itself is 12 feet, that means we're missing the leg, how high the loading dock is. So we don't know one of the legs, but we know the other one is 8 squared and the hypotenuse is 12 squared. So 8 squared is 64 and 12 squared is 144. Remember, if a leg is missing, we're going to subtract these two numbers, not add them. So 144 minus 64 is 80. So to get my final answer, we're going to take the square root. So the square root of 80 is, if we round to the tens place, 8.9. So remember, just word problems, you have to visualize this diagram, okay, and make sure you plug in the numbers where they go to figure out if the leg is missing or if the hypotenuse is missing. If the hypotenuse is missing, we add. If the leg is missing, we subtract.